Hello students, welcome to Saurav Sir's classes. Today we are going to solve a few questions on differential equations. The question is, consider the boundary value problem, abbreviated as BVP. d2y by dx2 is equal to fx with boundary conditions y0 is equal to y1 is equal to y dash 1, where f is a real valued continuous function on the closed interval 0, 1. Then which of the following are true? Option A, the given BVP has a unique solution for every f. Option B, the given BVP does not have a unique solution for some f. Option C, yx is equal to integration xt ft dt from 0 to x plus integration t minus x plus xt ft dt from x to 1 is a solution of the given BVP. And option D, yx is equal to integration from 0 to x minus t plus xt ft dt plus integration from x to 1 xt ft dt is a solution of the given BVP. Now, since f is a real valued continuous function, so its double integral exists and is unique. Thus, the given equation has a unique solution. Therefore, option A is correct and option B is incorrect. Now, for option C, on differentiating the given y under the integral sign, we get y dash x is equal to integration from 0 to x tft dt plus integration from x to 1 t minus 1 into ft dt. Now again differentiating the same way, we'll get y double dash x is equal to fx. Therefore, option C is correct. And for option D, on differentiating and again differentiating, that is on double differentiating, we'll get y double dash x is equal to fx, but y0 is equal to integration from 0 to 1 xt ft dt not equal to integration from 0 to 1 x minus t plus xt ft dt equal to y1. Therefore, option D is incorrect. Thus, option A and option C give us the correct answers.